Hello and welcome to the Bearded Math Man's YouTube channel. Here in this video, what we're going to be doing, we're going to be talking about graphing polynomial functions when they're factorable. So what we want to be able to do is basically sketch a fairly accurate graph of a polynomial function like, well, this one. So first thing you're going to do is you're going to look at the degree of the function, right? You're going to find the degree because here the degree is 4. The reason we know that is because if we were to distribute, we'd have x times x, that's x squared. We multiply that times x, that's x cubed, times another x, that's x to the 4th. So I know the degree is 4. The reason we want to find the degree is for, well, first of all, the end behavior. Because the degree is even, it's either going to be going down both ways or up both ways. If it were odd, it would go down left, up right, or up left and down right. Now, the other thing you want to do is you want to find the leading coefficient, because if it's positive, then it's going to be going up left or down left, up right, or up both ways. So these are the two cases, number 2 and number 3 right here, the two cases for a positive leading coefficient. So we know because n is 4 that we're going to have one of the first two cases, all right? Now, we need to decide if this leading coefficient is positive or negative. Well, when I multiply these two together, I get x squared, x cubed, negative x to the 4th. So this first one right here is how our graph is going to look as far as the end behaviors goes. It's going to go down left, it's going to go down right. All right, so that's how we know the end behavior. We went ahead and just looked at the leading coefficient and the degree. Now, the other thing degree tells you is the number of possible turning points is going to be one less. The maximum number is going to be one less than the degree. So the most turning points we could have for this function is 3 because the degree is 4. We will also be able to figure out how many x-intercepts we could possibly have. If the degree is even, you could have 0 up to whatever the degree is. So we could have 0, 1, 2, 3, or 4 x-intercepts for this graph. If it's an odd, you're always going to have at least 1. But whatever the degree is, that is the maximum number of x-intercepts you're going to have, right? Now, let's go ahead and find our y-intercept. That's the nenext thing we want to do. To find the y-intercept, you just put a 0 in for x. Just plug a 0 in everywhere you see it, and then you just do the arithmetic, right? So what we're going to have right here is 0 times, it doesn't even matter. You see, it's 0 times this, times this, times this. The things in the parentheses, those binomials, those are numbers. So we have a monomial times 3 binomials, and the monomial is equal to 0. So 0 times anything is 0, so we're going to go through the origin. Now, the next thing you want to do is you want to find the x-intercepts. The way you do that is you set the equation equal to 0 and you factor it. This one's already factored, right? But once you have it factored, take each factor and set each factor equal to 0 in its own equation, and then you just solve them. So this one's already solved, 0, 0, 3, 0, negative 2, 0, and this one is 1, 0. Remember, you're using order of operations, so be careful when you get negatives or coefficients other than 1. Just be careful, take your time, you'll get them right. All right, so here's what we got. We know what the end behavior is going to look like. This one's going down both ways. We know that the maximum number of turning points is 3. We know the maximum number of x-intercepts is 4. We do have 4 x-intercepts. So let's go ahead and put this stuff all on a graph, right? So I plotted the x-intercepts using Desmos. Looks like this, right? We know because the degree is even, the leading coefficient's negative, that it's going to be going down both ways. Now in reality it's curved, right? But I just wanted to show you that it's going down both ways. What we don't know is we don't know what happens between the x-intercepts. We know that we have 1, 2, 3, 4 x-intercepts. Now at an x-intercept, the graph could go all the way through, or it could just touch that point and turn around. So we don't really know what happens in between negative 2 and 0. It could be that it's going up, or it could be that the graph is going down. We don't know. We also don't know what's going on between the other two x-intercepts. So we have to find out. But we do know we found all of the x-intercepts. So what we do know for sure is that between negative 2 and 0, the graph will not cross the x-axis. So if it goes up, it's going to go up and then come back down and touch at 0, 0. If it goes down from here, it's going to go down and then come back up and go to 0, 0. So we got to figure out what's happening between those two. And to do that, all we're going to do is pick a number as an input for x between negative 2 and 0, right? If, say, for example, we pick negative 1. If we plug negative 1 in, and the output's a positive number, that tells us that the graph is going to be going up. If we plug in -1 and we get that the output is a negative number, then it's going to be going down. Same thing we're going to do between 0 and 1 and 1 and 3, right? So let's go ahead and plug in -1. So when we plug in -1, all we're really doing here is we don't really care what the number is. All we care is the sign, if it's positive or negative, because it turns out we won't be able to find the exact turning point without calculus, but we'll know if a turning point exists between these two intercepts. So plug in -1 and just do the math to figure out the sign. So this is a negative times another negative. This is positive, and this is positive. So a negative times a negative is positive, times 2 more positive. That stays positive. So it's going to be going up between -2 and 0. It won't be going down, right? There we go. Now, we're going to do the same thing between 0 and 1. So we're going to plug in 1/2. If our output's positive, it goes up. If it's negative, it goes down. So we plug in 1/2 and just look at the sign. You don't even have to figure out the exact number. So we have as a positive times a negative times 2 positives. Well, that's negative. So it's going to be going down between those two. Yeah, something like that. So we're going to have up between 2 and 0. It's going to go up and then back down. So we have a turning point somewhere in between. We don't know how high it is. We don't know exactly what the x input is, but all we're doing is sketching it. So we know between -2 and 0 it goes up. It's good enough. We also know between 0 and 1 it's going down. So we're going to have a turning point somewhere between those two. Now we have 2 turning points already. The maximum number of turning points, if we have a degree of 4, is 3. Right? That's maximum number of turning points. So it has to go up and then back down. It has to do that, because if it were to go down again, then we'd have 1, 2, 3 more turning points. That would give us a total of 5. We can't have 5 turning points if the degree is 4. So we know for sure what's going to happen, but let's just go ahead and verify. Let's plug in a 2, because 2 is between 1 and 3. You can pick any number you want in between 1 and 3. Any number you want to pick, you pick. So I picked 2 because it's easy. We got a positive times a negative times a positive times a negative. That's, of course, a positive number. So our graph's going to look something kind of like this. Now, of course, these are curved everywhere, and it's going to look a little bit more, well, it's called smooth and continuous, but that's a pretty decent sketch. And if you want to see what it looks like if you plug the function into Desmos, it looks just like this. So let's pull it all together, right? Let's do a summary. Here's what you're going to do. The first thing you're going to do is look at the degree and the sign of the leading coefficient, because it's going to tell you the end behavior, the possible number of x-intercepts, and the possible number of turning points. Then you're going to find the y-intercept. That's the easiest part, almost always. And then you're going to find the x-intercepts. You're going to have to set it equal to 0 and factor. Do you see? And then what you have to do is you have to figure out, is the graph going up or going down in between consecutive x-intercepts. That'll tell you the direction of the graph. It'll tell you if the turning points are above or below or actually on the x-axis. Yeah, so just real quick, let's run through one more. Let's say we had this one right here, x cubed plus 3x squared. Well, the degree is 3, and the leading coefficient is positive. So that means it's going to go down left and up right. And there is going to be at least one x-intercept, because if the degree is odd, there's always one x-intercept at least. It could be up to 3 x-intercepts, though. The maximum number of turning points is going to be 2. So let's find the y-intercept. You plug a 0 in, 0, 0. It's better to plug it in here to the original. No problems, right? Now, finding the x-intercepts, you set it equal to 0, and you factor. Here, you can take out an x squared. Do you see? You set each factor equal to 0, right? Well, 0 squared is 0, so x equals 0 is one answer, and x equals -3 is the other. Turns out this one's repeated. There's 2 of them. You get 0 and 0, but that's okay. So we have 2 x-intercepts, 2 unique x-intercepts, 1 y-intercept. It's the same. It's the origin, right? And so if we put those on a graph, here's what we got. So our end behavior tells us that it's going to go down, left, up, right. They won't be straight lines. They're going to be curved, but that just gives us an idea. So all we got to do is figure out in this one interval, we have to figure out, is the graph going up or is it going down? So we're going to plug in -2. -2 is in between. So it's best, it's easiest, you can plug -2 into the original and do all the math, or you can plug it into the factored form, which is what I did, because then it's easier to figure out. So -2 squared is positive, -2 plus 3 is positive, a positive times a positive is positive, of course, that means that it's going to be going up, not down. So the graph's going to be somewhere in between here and here. It's going up somehow or another. Now, this will actually be a nice turning point right here. It won't be, it'll be nice and smooth and continuous, but that's a decent idea of what the graph's going to look like. So, hey, a lot of information in here. You've got to know how to find leading coefficients. You got to be able to figure out degree if it's already factored, all kinds of stuff. If you're having trouble with any of the previous information, visit my website, thebeardedmathman.com. I will put a link in the description down below where you can access it. And there's going to be practice problems, other videos. Man, it's going to be great. Anyway, I hope this video has been helpful. If it has, give it a thumbs up, share it on social media. Let me know in the comments down below what questions or comments you have. I'd love to hear from you. Today is April 21st, 2020. We are in the middle of social distancing. Schools out, virtual classrooms. Hope you guys are all safe and sane. And hope to see you guys soon. Have a great day.